In this video, the network reduction function will be introduced. For this demonstration, we will use study case 02 contingency analysis. When dealing with a large network model, it can often be the case that some parts of the network are of little interest for the purposes of a particular analysis, or are of a confidential nature. Network reduction offers the means to remove these parts of the network and replace them with equivalent impedances and voltage sources. Reducing the network in this way also has the benefit of speeding up calculations, whilst preserving the integrity of the solution. The network reduction command is found in the additional functions toolbox. In this video we will look at a standard sort of network reduction, one suitable for static calculations, using the word equivalent method. We will create a boundary to define the area to be reduced. Let us assume that we wish to reduce the southeast part of the network. If we run a load flow, we can see the power flows on the circuits connecting the southeast grid to the rest of the network. There is a total of 110.6 megawatts exported from the southeast. We will now create a boundary at the other end of these lines, which will be used for the network reduction. The relevant cubicles can be multi-selected using the Control key, then the boundary is defined using right-click, Define Boundary. The orientation is set to busbar. This will mean that the interior of the boundary will be the southeast part of the network. The check split button can be used to check that the boundary is a closed loop, which is essential. Click OK to save the boundary definition. Now let us return to the network reduction command. The new boundary can be selected and we will use the default setting that the interior of the boundary is to be reduced. On the outputs page, we can see that there is an option to create a variation for the reduced network. This is the default setting, and it means that the changes can easily be reversed by deactivating the variation. On this page, we can select the option to verify the results. This means that the load flow results before and after the reduction will be compared. The command is executed, and the effect of the reduction can be seen on the graphic. Looking at the project overview, we see the network variation for the reduction. A new study case has been created, in which this variation is activated. Opening a network model manager, we see the equivalent voltage source that has been created to replace the reduced network. In the output window, the verification of results is shown. And if we run a load flow calculation, we see that, as expected, the active and reactive power flows are the same as before the reduction. If the original study case is reactivated, the variation is no longer active, and so the original network model is restored.